In this video we'll explore division, fractions, and remainders. Now how do we relate division and fractions? Because context does matter. When we see a problem that has a fraction 3/8, we're saying 3 pieces of a whole that's been split into 8. So if we take a pizza, split it 3 ways, we're looking at 3 of the 8 pieces of that single pizza. But when we see 3 divided by 8, that would be saying we have 3 pizzas that we're splitting among 8 people. So how can we relate these two? So let's take the idea of the pizzas. If I have 3 pizzas and we want to split it among 8 people, what we can do is take each pizza and split it into 8 pieces. Now that tells us that if I can take 1 piece from each pizza and give to the 8 people. So everybody will get 1 piece from each pizza. Now I could also shift that entire picture into 1 single pizza. If I put those 3 pieces on 1 pizza, I see that that is 3 out of 8 pieces. So what I know is that 3/8 is going to be equal to 3 divided by 8, or in more general terms, A over B is equal to A divided by B. Now when we're talking about negative numbers and fractions, it's going to follow the same rules as division. If we have 1 negative in our fraction, the entire fraction is negative. If we have 2 negatives in our fraction, then the entire fraction becomes positive. So we have negative 12 divided by 7, that means we have a negative 12 sevenths. If we have negative 15 over negative 4, that's a positive 15 fourths. So make sure to pay attention to your negatives. Now we're talking about having remainders and mixed numbers. Often we tell students to see how many times our divisor will divide into our dividend, and then we write a remainder. So 21 divided by 8, we know it goes in 2 times with a remainder of 5. And we can check it by saying 8 times 2 is 16, 16 plus 5 is 21. Problem is that whole notion of having a remainder doesn't really fit into any of our notions of division and how we can even think about it beyond just writing it as remainder. So what we have to look at instead is the notion that that remainder is really a fraction of a whole. And so what we can do is we can take our remainder and put that over our divisor and write a mixed number. So instead of writing 2 remainder 5, we could write that as 2 and 5/8 because it's 5 pieces left over out of 8 total. And if we wanted to do that as a picture, you'd have there's a whole, a second whole, and then I can look and say, well, there's 5 pieces out of 8, and if I count them, there would be 21 total pieces covered. Now, same thing happens with improper fractions. We know that A over B, which would be an improper fraction, if we wanted to write one, is equal to A divided by B. And we also know that when we do this division, if we have a remainder, we can just write it as a mixed number with a remainder over the divisor. So if I have 29 fourths, that's the same as 29 divided by 4, and that tells us that we have 7, because 4 times 7 is 28, and leaves us a remainder of 1 to get up to 29. And if we follow our rule that we just had a little bit ago, we could change this remainder 1 to the remainder over the divisor. So 29 divided by 4 is 7 and 1/4. And I could look at that as a picture as well. 1, 2, 3, 4, 5, 6, 7, and then I have that 1 piece. And if I count up all the shaded, I'd have 29 total pieces, and I'd be seeing that they're split into fourths.